Hello and welcome to The Explainer. In this episode, we're going to pull back the curtain on the real physical heart of the internet. We're going to follow the complete life cycle of a server. From the moment it's just a box on a shipping pallet to becoming the backbone of our digital lives. And what happens when it's finally time to say goodbye?
Think about it. We just take the internet for granted, don't we? But what's actually running the show? Behind every single click, every search, every stream, there's this massive, global, nervous system of hardware and software. Today, we're diving into the giant data centers where all this stuff lives, and we'll see the incredibly complex, coordinated effort it takes to keep it all humming. So, we've broken this journey down into 4 main parts. First, we'll get our hands dirty with the physical stuff: racks, rails, and cables. Then, we'll breathe life into the machine with software. After that, it's all about building a digital fortress to keep it safe. And finally, we'll put on our detective hats and learn how to troubleshoot when things go wrong.
All right, let's get started. Our story begins not in some abstract cloud, but right here on the concrete floor of a data center. Before a single line of code can run, you have this whole physical world of steel racks, power cords, and all the essential groundwork that absolutely everything else depends on.
Everything in a data center is built around one simple, standard unit of measurement: the U, or rack unit. It sounds basic, right? It's just 1.75 inches. But this little standard is the absolute key to everything. It's what lets companies pack thousands of components from totally different manufacturers together into these huge 42U tall cabinets. It's like the universal Lego brick for the internet.
Now, getting the rack itself installed is this surprisingly precise operation. It's not just about wheeling it into a spot. It's about creating a perfectly stable and secure foundation. Those leveling feet and stabilizers you see here, they are absolutely critical. An unbalanced rack is a huge safety hazard, especially when you start sliding in hundreds and hundreds of pounds of really expensive gear. This brings us to something that sounds boring but is one of the biggest challenges: managing the cables. And this quote just nails it. A messy spaghetti cabinet isn't just ugly, it's a real problem. It can literally choke off the airflow, cause things to overheat, and just imagine trying to find one bad cable in that mess when the system is down. It's an absolute nightmare.
And here you can see the difference in the real world. On the one hand, just bundling cables together is, it's a start, it's good. But the real professional standard is to completely separate your power cables from your data cables. Doing this makes a huge difference for cooling and airflow, and it makes tracing a single connection, especially when you're under pressure, way, way easier for the engineers.
So, the last physical step is picking your storage, and it's always this big trade-off between speed and cost. You've got your traditional hard drives, the HDDs. They're cheap and great for cold data, stuff you don't need to access often. Then you have SSDs, which are way faster and pretty much the standard for running operating systems and hot, frequently used data. But for the really intense stuff like AI training or heavy-duty computing, you go with NVMe. It's a beast, plugging directly into the PCIe slot for insane speeds.
Okay, so the physical foundation is all set up. But right now, our server is basically just a silent box of metal and plastic. In this next part, we give it a brain. We're shifting from the physical world to the digital, installing the operating system and getting it all ready for administration.
Installing an OS on a server is nothing like doing it on your laptop at home. Modern servers have these amazing integrated tools, like a Lifecycle controller. You just boot into this special environment and it guides you through the whole process, setting up storage, automatically loading all the right drivers, making sure you get a super stable and reliable installation right from the get-go.
You see, in a modern data center, one physical server almost never does just one thing. That's the magic of virtualization. The physical box is the host. It runs special software that basically carves up its hardware into multiple, totally isolated guest machines. Each guest thinks it's its own independent server. This lets a single box run dozens of different apps, which is just a huge win for efficiency. Now, how do you manage hundreds or even thousands of these servers without going crazy? You can't do it by hand. The answer is automation, using basic scripts. And don't let the word scripting scare you. The core ideas are actually really simple. You use variables to hold data,
conditionals for if this, then that decisions, and loops to do something over and over again. This is how one admin can push an update to an entire fleet of servers in an instant. So our server is up and running, it's functional, but its job has really just begun. Now we have to shift our focus from building it to protecting it. In this section, we're going to build that digital fortress, the one that secures our data and makes sure we can recover when things, and they will, go wrong.
And just take a look at what server professionals actually focus on. According to the CompTIA Server Plus certification, which is a big deal in the industry, a full quarter of the knowledge you need is all about security and disaster recovery. That's almost as much as administration and troubleshooting. It just goes to show you how absolutely central protection and planning are these days.
When we talk about data security, it's not just one thing. You have to protect data in its two different states. First, there's data at rest. That's all the information just sitting there on a hard drive. That gets protected with disk encryption. But then you have data in transit. That's data actively flying across the network, like in an email. That needs network-level encryption to keep it safe from anyone trying to listen.
A really core security practice is something called server hardening, and the whole idea is to reduce the server's attack surface. The philosophy is simple. If you don't need a feature, turn it off. If a network port isn't being used, close it. Only install the software you absolutely need. The less you expose to the outside world, the fewer doors and windows there are for someone to try and break in. Look, no matter how well you build a server, no matter how well you secure it, things will eventually fail. It's just a fact of life. But when that happens, it's not time to panic. It's time for methodical detective work to find the real cause and get things back online.
Professionals do not troubleshoot by just guessing and clicking around. They use a strict, logical methodology. This process forces you to be systematic. You gather evidence, you form a very specific theory about what's wrong, and then, and this is the most important part, you test that one theory by making just one single change. This stops you from making the problem even worse. And that last step, documentation, that's how the whole team learns from what happened. So what does that detective work actually look like? Well, it's all about recognizing patterns. For instance, if a server just starts shutting down randomly, a seasoned admin immediately thinks two things: power or heat. If the operating system won't boot up, they're going to check the storage right away. It's that logical jump from the symptom to the most likely cause that is the core skill of good troubleshooting.
So, from the physical racks to virtual machines, from building a fortress to troubleshooting the chaos, that's the journey. And it brings us to one last big question. As all this technology gets more and more powerful, more complex, where is the biggest challenge, really? Is it in the hardware? Is it the software? Or is it in the human ingenuity that we need to manage this whole thing? Thanks for joining us on The Explainer.